Hello class, this is your instructor Patrick Brooks. Today we're going to be going over Chapter 2 of the ER book, and this is your diagram basics. We kind of skipped Chapter 1. And we're going to right into it, and we're going to start in Chapter 2. So the topics we'll be covering today, we have schema versus a model. What is a schema, what is a model, and how do the two differ? We're going to define and dissect an entity. We're going to be getting into what is an entity and the component pieces of entities. Methodology. We are going to give a set of rules for building entities from the ground up. And grammar and presentation. We're going to be going over the English grammar and the presentation, which you will give to your client for feedback. Okay, so let's go ahead and jump right in. Okay, so a schema, as you can see, is a representation of how things are stored. An ER diagram is a very good example of a schema. Now, ER diagram is a little bit before a schema. A schema is kind of a concrete design, and then you have your physical model, which would be after you lay the tables out and actually create your database. So an ER is a representation of how we are going to store our data. Now, there are various reasons we do this. The main one being it is a very easy, and you'll find fun, way to create your database from the ground up. You start from it's kind of a top-down approach. You start from what you have, generalizations, and then you work your way down. And if you follow the methodology that works to the T, you'll start out with a general idea of what you want to do and end up with everything down to your database tables and keys and attributes. So we focus on what we know and we refine it, and it does make the process a lot smoother. This way we don't have to go back over and over everything. Well, there's usually more than one iteration with feedback, but it makes the process much smoother. We do it once, and we're usually in pretty good shape. We will just have to go over any changes that we make to it as part of the business cycle. So parts of an ER diagram. Well, you have your basic entity here. Entity is, as you can see, anything about which we wish to store data. Now, a good example of an entity, if we go back to the object-oriented programming paradigm, an entity is basically an object. Big parallels can be drawn between the two. Entity is something about which we wish to store data, and attributes are kind of like the data fields of those objects, in that they are data stored about an entity. Okay, so you should have taken at least one programming class, I should say, before this database class. So from an object-oriented programming paradigm, because I know we don't do much in the way of pure structured programming anymore, at least from an academic standpoint, entity can be thought of as an object, and an attribute can be thought of as its member as data fields. Okay, and if you look here, I have a little diagram. It's also in the book. In Chapter 2, this is the Chen-like ER diagram, and this is going to be your most popular ER diagram and what we'll use for this class. You see we have an entity called student. Okay, that's our entity. If you want to think of it in programming, that's our object. That's what we store data about. That's what we do things with. Okay, and here we have our attributes. In the Chen-like system, we store our attributes as ovals. Now we have several attributes here. I have phone, social security number, GPA, name, major, date of birth, and age. We have within attributes, keep in mind that attributes are basically just data fields. That's all they are. They're information we store about the student. Now we have several different kinds of them too. Here you notice I have multi-valued attribute with a pointer to phone. Okay. Composite attribute, derived attribute. What is a multi-valued attribute? And why is phone a multi-valued attribute? A multi-valued attribute is an attribute which can have more than one instance for a given entity. So it's anything an entity can have more than one of. And phone number is a very good example. I, for example, have a business phone, a cell phone. I know some people have a couple cell phones. You might have a work cell phone. You might have a personal cell phone. You might even have a home phone or Or heck, if you live in the 80s or 90s, you might even have a pager, right? So I have showed phone here as a multi-valued attribute, and it's double oval because that's how we show multi-valued attributes. That denotes multi-valued there. Okay. Social Security number. Notice it's a primary key. Social Security number is an excellent primary key. Remember, a primary key is supposed to be unique. It's supposed to uniquely identify an entity. And that's exactly what Social Security number does. You know, slip-ups do happen, but for the most part, you're not going to find two people around with the same Social Security number. For student, I also put GPA in there. I have name, okay? Now, this is a composite attribute. The rest of these three, and these three over here, are atomic attributes. Name is going to be composite. Why? Because it's composed of first, middle, and last. Okay? Name is a convenient grouping, convenient logical grouping for them, but I want to split them up in first, middle, and last in my database. That way I can sort by first name, or just last name, or just middle name without having to parse this name field string to do anything with it. Okay? So that's an example of a composite attribute. Another example might be, let's say we record student address. That's a really good one. We could break that down into street number, street name, zip code, city, state, country. So you get the picture. It's basically anything you can break down further would be a composite attribute. Okay, you don't necessarily have to break attributes down to the atomic level like this. I could just have a name string and get rid of first, middle, and last. There would really be nothing technically wrong with that, but I want to keep them as first, middle, last because it's convenient for me to do so. I may want to sort by first name, by last name. I may want to run reports based on those. Okay. Let's see, I also have major and date of birth here. Okay. Now, age I have as a derived attribute. It's a little dark over here, so you may not be able to read that very well, but that says derived attribute. Okay, and the derived attribute is an attribute that can be calculated from other data in the database. Okay, this is a good example here because I'm 35 years old, but next year I wouldn't expect anybody to go in manually and update my age to 36 in a database. Okay, what we do, that's just untenable. If you have, you know, say 100, 1,000, a million users, no one is going to update those entries every day and keep them current. So what I would do if I wanted to have an age attribute stored in my table, well, I'd calculate it from the date of birth. Okay? So that's what a derived attribute is. And notice I can show, it's not ultra clear here, but that outline is dashed, so we show them as a dashed oval, derived attributes. Okay? So multi-valued attribute, an attribute about which we can have more than, of which we can have more than one instance per entity. Phone number is an example. Gosh, what's another good example? Certification, degrees, okay? Social Security number is a good primary key. A primary key is a unique identifier. Social Security number is perfect in this respect, okay? GPA, just a regular atomic attribute. Composite attribute. Attribute that can be broken down into atomic elements, or that is in the database broken down into atomic elements. Name can be broken down into first, middle, last. Address could be broken down into, again, street number, street name, zip code, city, state. And derived attribute. An attribute that is calculated from another field in the database or in the table. Your entity should have keys. All of your entities should have keys. Okay? We need a way to uniquely identify each entity. Again, something like Social Security number would be perfect. There are identity fields you can use to make your own primary keys dynamically in databases, but a lot of the times they'll have a natural key, or if there's not a natural key available, you can make your own surrogate key. Okay? Weak and intersecting entities are a little bit special there. Weak entities do have what's called a weak key, and it's not necessarily a unique identifier. it helps to identify. But you basically combine the weak key with the primary key of the owner entity to identify a weak entity. So their key would really be the weak key plus the primary key of the owner entity. So they do have their own key. And don't worry, we'll get into weak entities later. I believe it's chapter 6, if I'm not mistaken. Okay, atomic attributes are attributes that cannot be broken down further, or attributes that are not broken down further, basically in the database. Okay, versus composite attributes, which are composed of parts. They do have component parts. Again, address would be number, street, city, state, zip would be the fields that we could break this address out into. And derived attributes are those that are calculated based on other fields or other attributes. Okay? Here's our methodology. We draw the entity, okay? Place the name on the entity, okay? Place attributes on it. Again, these are attributes. We connect them to the entity with line. Write out the grammar for the client. And we'll go over the grammar in just a moment. Now this is a very important part here. This is easy to overlook and say, oh man, this isn't fun. But this is very, very, very important, these 3 steps. Because it leads to the last 2. What we do is we elicit feedback from the customer, from the end user. If the customer or end user does not understand anything about entities, they don't understand anything about attributes, they don't understand anything about ER diagrams, and they may have a minimal understanding of tables, schemas, and databases. Okay, so what we need to do is help them out and write down in English what we perceive to be the case and what we're going to do. We'll include sample data as further reinforcement. We'll go ahead and give it to them, and they will give us our feedback. It's their business. It's their business process. They likely understand it better than we do. They may catch something, some false assumptions that we've made, something that we've done incorrectly, something that they'd like us to do. Okay? And they will give us feedback, and we will change based on that feedback. And that's your cycle. You go ahead and repeat that. And we refine that way. Okay? So the methodology, the grammar on is very important. This might not be the fun part. The fun part is drawing these and then mapping to the database, but these 3 steps are very important. So here's our preliminary grammar with just say any generic entity with a few attributes on it. And you'll find this in the book. This is excuse me. This is just a review. It's pretty straightforward in the book, but I thought I'd include it in here and we could talk about it just in case, so it's not a mystery. So we start out, this database records information about any generic entity. I'll go ahead and say student, since that's what we had above. For each student, we record, let's say, name, date of birth, major. Then, if the entity is atomic, we go ahead through all the entities and say, well, for each student, there will be one and only one name, let's say, for each student. Now, actually, this isn't a good example because this is for atomic, and what I'm talking about, name, is actually a composite attribute. So I'll go with date of birth for each entity. For each student, there will be one and only one date of birth for each student. The value for date of birth will not be subdivided. Okay, so that's how we approach an atomic entity. We basically use this grammar verbatim, and we go ahead and substitute the entity name and the attribute name in. And you know, really, if we think about it, date of birth could actually technically be a composite attribute. We could break that out into month, date, and year. But you know, in this case, we don't want to. We're just going to treat it as an atomic. We're not going to divide it. We're not going to subdivide it. Okay, so that was for atomic attributes. Now here is an example of a composite attribute. For each student, we will record name, which is composed of first, middle, last. First, middle, and last are the component parts of name. So you see, for composite attributes, You give the high-level overview, you give the overall attribute name, and then you break down into component parts and say these component parts are the component parts of the attribute. Then at the end, we want to state our primary key. We want to state what identifies the attribute. For each student, we have the following primary key: Social Security number. Now, there are special cases, and they will be a little bit later on, about when we don't have primary keys, but for right now, we are going to have them, so I'm not worried about covering that this second. So if we want to go ahead back from over the top, we'll go ahead and go over this. This database records information about students. For each student, we record name, Social Security number, date of birth. For each student, there will be one and only one Social Security number for each student. The value for a Social Security number will not be subdivided. Okay, so whenever the first atomic. Now I'll go over the second atomic. For each student, there will be one and only one date of birth for each entity. The value for date of birth will not be subdivided. Okay, now I'm left with name, which is composite. So here we go. For each student, we will record name, which is composed of first, middle, last. First, middle, and last are the component parts of name. For each student, we have the following primary key: Social Security number. So that's our grammar. We will develop this as the class goes on. This will get more involved, but it's pretty easy. Of course, it has to be. We are breaking it down so that the business person can understand our technical speak. Okay? So we'll go ahead and go over another example here. And I have a full example. I based this on what we had up here. If you look, the attributes and the entities are the same. Okay. This database records data about students. For each student in the database, we record phone number, Social Security number, GPA, name, major, date of birth, and age. Okay, and then we go on with the attributes. For each student, we record phone number. There may be more than one phone number for each student. So that's how we handle multi-valued attributes. The value for a phone number will not be subdivided. So we were saying that this is an atomic attribute. Again, we could split this one up as well. We could say, area code and phone number, or we could even say area code, exchange, and last four. Okay. For each student, there always will be one and only one Social Security number for each student. The value for Social Security number will not be subdivided. So even though this is the primary key, I don't mention that right now. For each student, there always will be one and only one GPA. The value for GPA will not be subdivided. For each student, there always will be only one and only one major. The value for major will not be subdivided. For each student, there will always be one and only one date of birth for each student. The value of date of birth will not be subdivided. For each student, there will exist age, which will be derived from the database. So this is how we handle our derived attributes. For each student, there will exist age, which will be derived from the database. Okay. For each student, we will record name, which is composed of first, middle, last. First, middle, and last are the component parts of name, as we discussed earlier. For each student, we will have the following key: Social Security number. Okay, that's from the top. And we also go ahead and show sample data. There we go. So this is how I want you to lay your tables out. Table name, your attributes up here with enough spacing. Obviously I couldn't, this is a PowerPoint presentation, I wanted to make it visible. I don't have a whole lot of spacing, so I had to work with what I had. But we spaced these out as much as possible to make sense of them, okay? So we have phone number, Social Security number, GPA, first, middle, last, major, date of birth, and age. So I have all of the attributes here. Now notice what I did with first, middle, and last. This is the convention for showing atomic attributes. When name is broken down into first, middle, and last. The first, middle, and last will be called, say, name.first, name.middle, and name.last. So that's how we show those atomic attributes here, or the atomic parts of the composite attributes. So I have a few entries here. Notice I have phone number under phone. These are fictitious. Phone number under phone, Social Security number under SSN, GPA under GPA, although I'm skewing a little bit here, and it's okay because I just didn't have enough space to work with everything. First, middle, and last under their respective columns, and major, date of birth, and age the same. Okay, so that's pretty much it. This chapter is fairly short, and the reason is, they're introducing a new concept. It's a lot to sort of sink in, even though it's rather simple. Okay, so if you have any questions, please feel free to let me know directly. Again, you should probably email me with any questions rather than posting in the discussion area, unless you think it's something that would be good to share with the class or that your classmates could answer. Otherwise, you can email me directly. My email is in the syllabus. It's pbrooks1@uwf.edu. You're welcome to call me. You have my cell number listed there in the syllabus, although I may or may not answer depending on what I'm doing. So if you email me, I will get back to you within a day. That's not promised over the weekend, but usually that'll be the case too. Okay, so I'll see you at the next lecture.